Hi, my name is Mel, and the following presentation will provide an in-depth exploration of various network topologies and protocols. It covers their structures, operational principles, setup process, pros and cons, and practical use cases to help understand how networks are designed and managed effectively. We will begin by introducing core network topology concepts, then explore detailed topologies like bus, ring, star, mesh, and hybrid types. Following this, we will discuss key network protocols including Ethernet, token ring, FDDI, and wireless standards, closing with practical setup and security considerations. Understanding network topology fundamentals is essential for designing efficient communication systems. This section covers the definition of topology, the key components such as nodes and links, and how to select an appropriate topology based on specific criteria. Network topology defines the physical or logical arrangement of network devices and connections. It impacts network performance, scalability, fault tolerance, and management, making it a critical factor in network design. Networks comprise of nodes, devices like computers and servers, that's nodes, links, which are communication channels, and other hardware components, and that'd be like routers, switches, modems, cables, servers, things like that, and devices, anything like that, okay? Understanding these elements helps visualize and manage network structure effectively. Choosing a topology depends on factors like cost, scalability, fault tolerance, performance, and ease of maintenance. Selecting the right topology ensures the network meets organizational needs and adapts to future growth. Bus technology connects all devices to a single communication line. This section explains its physical layout, how data transmission occurs, and evaluates its advantages, disadvantages, and maybe typical use scenarios. In bus topology, all networks are connected to a single backbone cable. Terminators at the end prevent signal reflections, and each device communicates by placing data onto the shared bus. Data is transmitted in both directions along the bus. Devices listen for their address and respond accordingly, but only one device can transmit at a time to avoid collisions, okay? Bus topology is simple and cost effective, but suffers from very limited scalability and vulnerable to cable failures. It is often used in very small or temporary networks where cost is a priority. Also doesn't have a great deal of fault tolerance or redundancy. Generally, I would not recommend bus topology, even with very small companies or temporary, because it's honestly it's a lot slower and very difficult, can be difficult to set up, because if the cable breaks or there's any kind of issue anywhere along the line, if a server or end or a node goes down, then the whole network's off. So look, it's up to people to choose if they want to, but I honestly wouldn't recommend it. Okay, ring topology connects nodes in a circular manner to allow data to flow sequentially. This section covers its structure, token passing protocols that manage data flow, and practical implementation steps and applications. Each node connects to exactly two other nodes, forming a closed loop. Data travels in one direction around the ring, passing through each node until it reaches its destination. Token passing controls which device can send data by circulating a token. This reduces collisions and improves reliability. making ring topology suitable for time-sensitive applications. Setting up ring topology requires careful cabling and token management. It is used in environments requiring orderly transmission, such as legacy, LANs, which is local area networks, and some industrial networks. But also going about ring, it is also slow and subject to failures as well, like if cabling breaks or part of the ring breaks. And again, that's not something I would generally recommend, maybe in an industrial complex, but again, look, if you're wanting redundancy and reliability, I generally would not recommend ring. So now we're going to talk about star topology, which features a central hub connecting all devices. This section describes the physical setup, communication processes, failure scenarios, and considerations for installation and scalability. Devices connect individually to a central hub or switch. The hub manages data traffic and acts as a single point of communication with the network. Data sent from a device passes through the hub before reaching its destinations. If a node failed, the rest of the network remains operational. However, hub failure can disrupt the entire network. So hubs aren't generally used. Routers and switches are generally used now. And you would definitely, in all of these scenarios, you would have to have some level of redundancy, not just one router and switch. You would have probably two central routers at least. All right, and like obviously redundancy built in. Like this is probably way more reliable. How cost effective it is, you'd have to look at that. This is more reliable, better, you can expand this network a lot easier than you can the others. I would recommend this in most instances, but there would be considerations to that. Star topology is easy to install and scale by adding new nodes to the hub. It is widely used in home and office networks due to its robustness and manageability, yes. Mesh topology provides multiple paths between nodes for high redundancy. This section covers full and partial mesh types, fault tolerance benefits, setup complexities, and deployment scenarios. And look, mesh topologies for like bigger companies or bigger industrial would be more preferable because it's got a lot more redundancy, a lot more fault tolerance. Can be expensive and difficult to set up, but look, mesh is generally better. I would recommend mesh over everything else generally, but look, if not that, then star. But look, there are other, you can have hybrid, which we will talk about as well. In a full mesh, every node connects to all others, ensuring maximum redundancy. Partial mesh only connects some nodes, balancing cost and fault tolerance. So having a full mesh or a partial mesh, it's something you might want to consider, maybe having partial mesh, because at least then you've got some redundancy. Full mesh is very good, but can be expensive, okay? Mesh networks can reroute data if links or nodes fail, minimizing downtime, enhancing reliability for mission-critical systems. Mesh topology is complex and expensive to implement, often used in backbone networks, data centers, and wireless ad hoc networks where reliability is paramount. Yeah, so look, I think, like financial institutions would probably have mesh at least of some description. A lot of other places, either if it's full mesh or even just as backbone, whatever, they would have this sort of thing. Tree and hybrid topologies integrate features from multiple designs to optimize performance and scalability. This section explains their structures, benefits, and real-world applications. A lot of people would have this sort of stuff too. And look, generally probably pretty good. Tree topology arranges node and hierarchy resembling a tree, combining star and bus topologies. It supports scalable, organized expansion of networks. Hybrid technologies blend two or more technologies, leveraging their strength while mitigating weaknesses, tailored for complex networking needs. And look, a lot of people do use hybrid, quite honestly, because you're going to need different things for different areas of your network. All right. And that's just reality. And cost will come into it, and setting up will come into it too. These topologies are commonly used in enterprise and campus networks where flexibility, performance, and fault tolerance are essential. Yes. Look, and a lot of big companies will use these too, you know. Protocols define communication rules on the network. So the protocols are just rules of how something operates. This section introduces their role in common protocol layers like OSI and TCP/IP and criteria for selecting appropriate protocols. Protocols are standardized rules enabling devices to communicate effectively, ensuring data integrity, timing, and error handling. The OSI and TCP/IP models organize protocols in layers, each responsible for specific communication functions, simplifying design and troubleshooting. Selecting protocols depends on compatibility, performance, security, and network requirements to ensure optimal communication. Ethernet is the most widely used wired technology. This section covers its communication basics, various types and media and setup and troubleshooting tips. A lot of people will use optical fibre in, like, especially backbone, connecting servers or long distance, because Ethernet has issues with that. Optical fibre can transmit a lot longer. Optical fibre can be more expensive than Ethernet, although the cost is coming down. Ethernet is generally reliable, but it's slower than optical fibre as well. So this is about Ethernet and the IEEE 802.3 protocols, okay? Ethernet uses frame-based communication over physical media, using MAC addresses for device identification and CSMA and CD to manage access on shared media. I'm going to do like a separate thing about Ethernet and these sorts of protocols. I'm just going through network topology and just giving the basics here, but I will go through all of these in detail in later videos. Ethernet standards include 10 base T, 100 base TX, and gigabit Ethernet using copper cables or fibre optics depending on speed and distance requirements. And look, honestly, fibre optics would be used in a lot of cases, not copper. You can use multi-core copper, but like fibre optics can be multi-core as well and generally a lot better and faster, okay? Proper cabling, device configuration, and diagnostic tools help Ethernet networks function reliably and issues are quickly resolved. This section examines token ring and FDDI protocols, describing their operational benefits and consideration for modern network deployment. And honestly, I would not recommend token ring. Honestly, it's not that great. Honestly, it's a legacy thing that I would replace, quite honestly, if you could. Token ring uses a token passing method in a ring topology to control network access, reducing collisions and supporting deterministic communication. So it is a lot slower and subject to a lot of fault issues if something breaks, all right? And not a lot of redundancy here either. So it's, look, if you want to use it, great. I wouldn't recommend it, but okay. FDDI provides high-speed data transmission over fibre optics in a dual ring topology, offering enhanced reliability and bandwidth for backbone networks. So if you had like dual ring topology or 3-ring topology, you might get like redundancy there. But again, you know, It is what it is. While largely replaced by Ethernet, which it has been absolutely, token ring and FDDI concepts influence modern protocol. Considerations include compatibility costs and specific application needs. Honestly, I would replace token ring with Ethernet. Seriously, that is something you should do. If you've got, legacy systems, you need to go Ethernet and not token ring. It's got, not all that great. Wireless networks operate with distinct topologies and protocols. This section covers wireless topology types, key protocols like Wi-Fi, Bluetooth, security and setup, and best practices. Wireless topologies include WLAN, which is wireless LAN, WPAN, which is wireless personal area network, and wireless MAN, wide area network or managerial area network. For metropolitan area networking, each suitable different coverage needs. So personal area network, metropolitan area network, all these types, okay? These are all different types of area networks you can have. Local area network would be like home office, personal area would be personal use, metropolitan over a big area, city or towns, okay? Wi-Fi supports high-speed internet access. Bluetooth enables short-range device communication, and Zigbee is optimized for low-power sensor networks, okay? Proper wireless setup involves configuring access points or wireless access point, selecting suitable protocols, and implementing security measures like WPA3 encryption to protect network data. And yes, please have WPA3 encryption. Okay, that is really important because the others are outdated. Understanding network topologies and protocols is essential for designing robust, efficient, and scalable networks. By choosing appropriate structures and communication standards, optimization, connectivity, and performance. Okay, so this is just a very basic overview, but it's just something to give you an idea of what network topology is, what it means. It basically just means how things are connected and how they communicate with each other in a network. Okay, thank you for your time.